Hi, I'm Chris DiMartino, an applications engineer at Modelithics. Welcome to this video on Modelithics nonlinear diode models. Let's begin. The Modelithics Complete Library is a large collection of simulation models for components from many of today's popular vendors. Included in the Modelithics Complete Library is a sizable selection of models for different types of diodes. In this video, we'll go over these models and show some application circuits that were designed using Modelithics models for different diodes. Let's get started. Included in the Modelithics Complete Library is an assortment of models for different types of diodes, including Schottky, varactor, and pin diodes. These diodes are from different vendors, including MACOM, Skyworks, Infineon, and others. Let's dive into one of these models. Here we have the Modelithics nonlinear model for the SMV 1763-040LF varactor diode from Skyworks. Let's pull up the datasheet for this model. Remember that every Modelithics model comes with its own model information datasheet. On the first page of the datasheet, you'll see this model features box at the top. This tells you the validated frequency range of the model, which in this case is DC to 20 GHz. We see that the model is substrate scalable, temperature scalable, and pad scalable. The measurements that were performed to validate the model are also shown here. In this case, these measurements include DC IV, multi-bias S parameters, capacitance versus voltage, and resistance versus voltage. So let's elaborate some more here, starting with temperature scalability. As we see, this model is validated over a temperature range of -55 to +100 degrees C. If you scroll down the datasheet, you'll see the DC IV characteristics over temperature. Now let's move on to substrate scalability. This model was developed by performing measurements using 3 different substrates. Specifically, these substrates are 4mm Rogers 4350B, 20mm Rogers 4003C, and 60mm Rogers 4003C. Performing measurements using these different substrates enables the model to be substrate scalable. Substrate scalability is quantified by this H/epsilon-r ratio, in which H is the substrate height in mils and epsilon-r is the dielectric constant. So this model is validated for all substrates with an H/epsilon-r ratio that falls between 1 and 17. Substrate scalability is critical because a component's performance does depend on the substrate on which it's mounted. For this model, if you scroll down the datasheet, you'll see this graph here, which shows S11 when using different substrates. You can see how the results are different for each of the 3 substrates. So, this demonstrates the importance of using substrate scalable models in a design. The model also scales with respect to the solder pad dimensions. You'll find the validated range of pad dimensions here in the model datasheet. Now that we've gone over this model in some detail, let's look at an example circuit that was designed with the same model for the SMV 1763-040LF varactor diode. This example is a tunable filter which you can read about in application note 86 from the Modelithics website. This is the topology used for this design. To realize a tunable filter, we'll replace the capacitors with varactor diodes. Here's the complete schematic of the tunable filter designed in Keysight ADS. We see D1 through D4, which are the varactors represented by the Modelithics model. In addition, Modelithics microwave global models are used for all the capacitors and inductors in this design. Shown here is one of the tunable filters that was built and measured. And here's the frequency response for 3 different tuning voltages. The solid blue traces represent the simulated results, while the dash traces represent measured data of 3 tunable filters. We see good agreement between the simulated results and the measured data. Again, for more information, check out Application Note 86. Let's now turn our attention to a different model. Here we have the Modelithics model for the Infineon BAS70 Schottky diode. Let's take a look at the datasheet for this model. Again, the model is temperature and substrate scalable. Measurement validations include DC-IV, capacitance versus voltage, power compression, and S parameters. Let's scroll down and we'll see DC-IV over temperature, followed by this capacitance versus voltage graph. Go further down and we'll see the power compression at zero bias at 850 MHz. Finally, you can also see S11 over different substrates, as well as S11 with one substrate over different bias voltages. Let's also look at another application circuit designed with the same model for the Infineon BAS70 Schottky diode. This is a detector design which you can read about in Application Note 84. Here's the complete schematic in ADS that includes the Modelithics model for the BAS70 Schottky diode. The design also includes Modelithics microwave global models for the RLC components. This is one of 3 detectors that was built and measured. Here you can see the DC output voltage versus RF input power at 2.45 GHz. The solid red trace represents the simulated data, while the symbols represent the average measured DC output voltage of the 3 detectors. Again, for more information, check out Application Note 84. So in summary, Modelithics offers an array of models for different types of diodes that can surely help designers. In this video, we've discussed only 2 models that are available. To see a complete list of models that Modelithics offers, visit www.modelithics.com. There, you can visit the page for the complete library and then select this View Model Listing button. You can then sort through all of the available models. Well, that wraps up this video. For more information, visit www.modelithics.com or you can email sales@modelithics.com.